And there we go. All right. So last time we talked about errors. Now errors is directly tied into the power of the test. So right now I think we'll just review what we have for errors. So we have this. So remember over here is going to be my null is true. But in reality, actually that's not what, that's a true null means. Sorry, I see. Messing this thing up already today. This is my null hypothesis over here. Okay, this is what I think it is on the left, and it's what it is in reality on the right. So that's what we'll do here. And what happens here is we're going to set a level of alpha. Okay, that alpha level is where I make my cutoff line be something too rare or something not rare enough. Okay, so over here, this side is going to be true, and over here, this side is going to be false. Okay, so that's how I determine if that decimal value, that p value that I get is smaller, which means it's going to be out here. Okay, that's when we're going to make an error. Okay, so that means that my null hypothesis was true. Okay. If my null hypothesis is true, but I reject it, that is going to be an error. Okay, that error is, again, what I just highlighted in. This is the type 1 error. And again, it has that letter of alpha. Okay. However, if my null hypothesis is true and I fail to reject it, okay, that's going to be correct. So we've actually filled out this chart before, but I wanted to start here. Okay, so right there is my type 1 error. Over here on the left-hand side, this little area right here. So if I got this, so let's say I got a mark right there. Okay, obviously, if I was comparing that to my null hypothesis, this is not going to be rare at all. So that means that I would fail to reject my null hypothesis. But in reality, I would need to reject that. But in reality, it's actually very, very rare. So that is going to be my other type of error. This is my type 2 error. And again, that's beta. So over here on the chart thing, if I have a false null hypothesis that I fail to reject, that is going to be that's wrong. That is an error. So this is my type 2 error. So that means this is going to be the correct decision if my null hypothesis is false. Now, to get into what we consider the power of the test. Okay, so we had to talk about what the power of a test is. The power of a test against a specific is the probability of correctly rejecting a null hypothesis. Okay, what it boils down to it is the ability to correctly reject the null hypothesis. Okay, we detected that. So out here, so if I'm talking about what power is, and I go ahead and change my thing to something in purple, and I highlight this, I'm sure that sounds great on the old micro, on the video. You can't even see that that's power, can you? Maybe. Good enough. Okay, so the power is the ability to correctly reject a null hypothesis. Okay, and it's the probability that I do that. So that means if I slide depending on which way I slide that alpha level, is going to depend upon where that is. Now, in reality, we have a formula. I said that. Well, I don't know what my issue is with that today. Never say that. Anyway, the power is going to be 1 minus beta. Okay, which is so 1 minus my likelihood of making this type 2 error. So you can't see me swinging my pen around, but here's my type 2 error. Here's beta. So that means if we take 1 minus beta, that's going to leave me with everything left over here then to be my power, or the ability to correctly reject a null hypothesis. Okay. In practice, we carry out the test in hope of showing that the null hypothesis is false, so high power is important. Okay, we want to have the ability to correctly reject that null hypothesis, a false null. Okay. All right, so let's see if we can tie all these together with a few more examples. So we'll scroll back up in our notes to get to example 5. We learned that during the sloth sampling activity, which we did not do, this was, we had to change this over to the, no, it's irrelevant. What we had to change it to, we had to change it to a movie activity. We learned that during the sloth sampling activity, the World Wildlife Federation will declare the three-toed sloth in danger if less than 10% of the sloths in any given wildlife sanctuary are three-toed. We want to conduct a hypothesis test to determine if the three-toed sloth should be considered endangered. Okay, so again, this will go in, and this is a nice little tie back to what we were talking about on Friday. When we do a hypothesis test, we're going to have a null hypothesis and an alternate hypothesis. My null hypothesis, remember, is going to be a population parameter. My population parameter is going to be 10. So we're going to take a sample and try to infer that upon a population. Okay, if my population, if that proportion of the sample is greater than 10%, I don't care. That's great. The sloths aren't endangered. However, if it's less than 10%, then they would be endangered. So that means that my alternate, that's what I had to pay attention to in my alternate hypothesis, is that if it's less than. So we're going to come over here and go P is the true population proportion. Man, I'm pretty sloppy today, so I'll slow down. Is a true proportion of three-toed sloths in sanctuary. Okay, so again, we had to define what that population parameter is that we are trying to make an inference for. All right, so type 1 error. So now this is just where you have to think, it could just be straightforward. As far as you know, in a type 1 error, we're going to reject a null hypothesis when I shouldn't have. Or a type 2 errors when I didn't reject it, but I should have. So again, it is figuring out what you need to do to make that happen inside your gray matter upstairs. Okay, I got to the point where I started to picture it. I tried to picture it on a bell curve to see where it landed at. So in that type 1 error, it's going to be something very, very unique. So we're going to conclude that, so in type 1 error, then we would conclude that, what would we conclude? The proportion of three-toed sloths is, so if we reject my null, I say my null is that it is 10%. So if I reject that, that means I'm saying that it is less than 10%. When in reality it is greater. So on a type 2 error, then we're going to conclude that the proportion of three-toed sloths is greater than 10 or is 10% or greater when it's not. I shouldn't say the not is too general when it's actually less than 10. I gotta quit doing that. All right, so again, half of this is being able to describe the error. So we have described the error. We also have to talk about the consequence of the error. So in a type 1 error, if we concluded that the three-toed sloth is less than 10%, that means that we're going to put it on the endangered species list. But in reality, I didn't need to put it on the endangered species list because I didn't meet that. So what's the consequence of that? They get put on the endangered species list and they get all the protections of that, but yet it's just extra animals on the endangered species list. Probably maybe it may cost us more as far as getting the resources that we put into keeping endangered species around. Okay, type 2 error. That's going to be something we got a fairly large proportion in this case, so that means that we didn't put the three-toed sloths on the list. However, in reality, the proportion is below 10%, and they really should be. So now the three-toed sloth does not make it onto the endangered species list, but in reality, it should have been. So now we have to decide which type of error is more serious. Any takers?
Type 2.
Yeah. We'll say our type 2 error is more serious because three-toed sloth is not on endangered species. When it should be. So again, typically I find that the type 2 error is more serious. Now I can't say that rule that's a hard fast rule to stand by. Sometimes that matters and opinion matters. If we go back up to the example 4 that we did when we talked about that, I think it was during 4th hour. They thought the expense of sending away potatoes and getting more potatoes back would be more, and that would be more costly than making potato chips from bad potatoes, because their theory was they're just blemished. It's not actually going to affect the final output of the product of the potato chip. So again, sometimes perspective comes into that. I still disagreed with them or that small group, but there was a small group that thought that too. So I guess with that said, I'm going to read through your on a test. I'm going to read through what you gave me as your reasoning, and I'll probably do my best to keep an open mind. But you're going to have to be very, very convincing if you're going the other way on what I have on the key. I guess that sounds bad, but yeah, sometimes that's the way it is. All right. Excuse me. All right. A new vaccine has just been developed to prevent the infection from a coronavirus. Unfortunately, the vaccine has the possibility of being highly toxic to the patient. In order to be approved, the FDA, the vaccine must not result in any high level of toxicity in more than 2% of the patients. All right. So again, our hypotheses, we're going to have a null hypothesis and we're going to have an alternate hypothesis. The null hypothesis is always my statement of equality. So that means that the proportion of my sample is 2%, or in this case, or less, because it's okay for, again, we're talking about, the toxicity of something. And if it's less than 0.02, then that is okay. So it's all falling into that category. That's just my cutoff. That's what I'm paying attention to. Okay, we're worried where we have to go with the alternate hypothesis. If that proportion was greater than 0.02, then we have to be concerned. Okay, and now that we've introduced a P, a population proportion, we have to describe what that is. P is the true proportion of patients experiencing spelling fails me again. Experiencing toxicity when taking vaccine. And we wrote this question, did I spell vaccine? Last February. So I guess in this case we could talk about the proportion of people that have bad reactions to the vaccine as well. Another way, and I don't know why I popped that in there. Let's just move on. Type 1 error. Okay. What would we conclude in a type 1 error? So again, I don't know. Here we go. So when I think of I'm going to picture this. Again, my type 1 error is going to occur way out here. And if something that happens way out here, that means it's really rare. So we would conclude that vaccine is toxic. But in reality, it is not. Nope. I'm trying to avoid is not. That's just too vague. Yeah, that's fine in here. Okay. So what? Let's write the. We'll just go ahead and write the consequence in there. What is my consequence? We concluded it's too toxic, but in reality, it's not. So that means that what happens? Determine vaccine is bad and not use good vaccine. Okay, which sounds bad. I have a vaccine, but I determined it's too toxic, so I don't use it. But in reality, I could be using it because it's not toxic. So that's a pretty bad error. Okay, and then I have to spend more resources on developing another vaccine. Okay, so let's go through the type 2 error. So again, in a type 2 error, again, it's going to be something in here. It's going to be something that's not very uncommon. So therefore, I'm going to fail to reject something, but in reality, I should have rejected it. All right, so we're going to conclude that vaccine is not toxic, but it really is toxic to patients. Consequence here. Think about this. So we conclude the vaccine is not toxic, but in reality, it is toxic. So now I've had this vaccine. I have deemed it good to use. It's non-toxic. I give it to a ton of people. However, in reality, it was toxic. And now I've made many, many people sick. So now both errors in this case are pretty bad. Okay, but which one's the worst error? Again, probably the type 2. Will approve a dangerous vaccine. And there, I mean, and there, in a nutshell, is I know why some people are concerned about taking the vaccine. They felt like the process was rushed. Okay, so if that was the case here, I mean, and errors like this could have been made. But I think I haven't done a ton of research on this. I think in reality, I think to my knowledge, the vaccine was pretty much done because they'd already and we just had to tweak it a little bit to make it work. And then two is there's a ton of red tape that it didn't have to pass through. So but anyway, I'll stop there. That can get very political, so I won't go there. All right. So now let's go back to the power of the test. Okay, the power of the test is this right here. It is our ability to correctly reject a false null hypothesis. Okay, so this alpha level, if I slide the alpha level in the left direction and I make that bigger, that means it's my ability to correctly reject a false null hypothesis. So when I slide my alpha level to the left, I am increasing my type 1 errors, but my test has become more powerful because I'm going to catch that false null hypothesis. Okay, that's what I'm after. Okay, and that and again 1 minus b is how I do that, but it's understanding it equation wise, but it's more probably to interpret, be able to interpret it concept wise. Okay, so let's talk about factors that can increase that power of that test. We can increase the significance level. Whoops. Sorry, I'm gonna start with number 1. I'll come back to number 1. So now I go back to this one again. It's really easy to see the errors if there's a large difference between the actual mean and the hypothesized mean. Then it's easy to, you're going to have a lot of power, and it's going to be very easy to tell that. Okay, so when they're not, so a large difference between the hypothesized value and the parameter and its true value, that is going to create a lot of power. Okay, which I could see on that diagram. I drew that in there. But if I had a curve that was centered here and the real curve was centered here, there isn't a lot of difference in those curves. So again, wherever I set this alpha level, again, makes that determines kind of where we're at, that significance level. Okay, we could also increase the sample size, which is going to decrease the amount of variability again. That is also something that can increase our power, because again, it's going to separate those curves, it's going to make those taller and narrower. And lastly, a smaller inherent variability in the measured response. Okay, so what happens is I don't say that's where we're going to stop at, because we're going to keep on going. But we're going to perform a significance test. Okay. Now, when we created an interval, we had an acronym to go by. It was PANIC. The acronym that we're going to go by in conducting a hypothesis test is going to be PHANTOMS. Okay. So again, we're going to list all the parameters. This one actually is much easier on a hypothesis test, because as soon as we write our hypotheses and say that P equals 10%, well, we got to define what P is. So that has a more natural flow to it than when we do the parameters inside of an interval. And typically, a lot of times I use that just to write down all my given information. Okay, so even before we write the parameters, typically we're going to write the hypotheses. Okay, sorry. Again, we have a null hypothesis and we have an alternate hypothesis, and then we're going to have P equals something, and P is going to be greater than, less than, or not equal to, all those fun steps. And then we're going to define what P is. Okay. Assumptions. And again, our assumptions are going to go back to our same 3. The first one is going to be random sample. Now, I noticed it was really weird. I don't think you guys were bad at it. Oh yeah, we need to go over tests, don't we? We'll see if we have time at the end. You guys were bad at it all. For some reason, one of my hours was just say random sample and be done, but it's a random sample from our population. Our second assumption is going to be approximately normal. And again, because we're still dealing with proportions, it's still going to be n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. And then our last one is always going to be independency. And the fact that my sample size has to be less than 10% of the population. Here we're going to have a name of test. And again, my name is going to be either a 1 proportion. Well, right now it's going to be, since it's a proportion, it's always going to be a Z. So whenever we do the proportion, it's going to be a Z procedure, whether it's a Z interval or a Z test, it's going to be Z. Okay. After that, we're going to do the test statistic. Okay, so we're going to need z equals some number. We're going to obtain a p-value. So we're going to have the p-value equals some number. Well, next we're going to make a decision. Decision looks completely wrong, but I don't know why. Anyway, do we know what our decision is? That's when we either reject or fail to reject. And lastly, we're going to state a conclusion. And we can actually write all this kind of in one statement, and this is going to be, and that's, sorry, since our p-value is greater than alpha, we will, or it could be less than alpha. Since our p-value is greater than alpha slash, how do I clean that up? I don't know if I'll even understand what that symbol means when you read through your notes, but I'm going to erase that. We're going to go with is greater than alpha. We will. So what happens if my p-value is greater than alpha? What do we decide we do? We will fail to reject the null. There is insufficient evidence to suggest alternate, oops, nope, don't want that. HA in context. Okay, so again, I'll highlight this because I left all that. There's no sense of writing it out. There's no context. It's just going to make this murky. But whenever we make a conclusion, the conclusion always has to be in terms of the alternate hypothesis. So we'll write that somewhere down here. We'll turn that into a red pen and make sure we underline that. Conclusion always in terms of alternate hypothesis. So up here, I'll write another one. If it's less than alpha, we will reject the null. And again, it's just practice. Okay, when we get into this. So again, extend that little p-value talk that we had the other day. It's the p-value, again, is the probability of getting a z statistic this large or larger in a specified direction by my alternate hypothesis. So my alternate hypothesis, so out here on a one-tailed test, we could be out here when p is greater than p sub naught. Okay, and that's going to be my critical z value is going to be here, and my p-value is going to be there. That's what my p-value is that probability. So like there's one in your homework, okay? It references a z. Find the p-value given a z-score of 2.12 or something like that. Well, all that is going to your table and finding what the p-value is for that. Okay, we could have an alternate hypothesis that says my proportion is less than my null portion, and so that's going to be here. Okay, I'll have a z-score here, and again, my p-values are there and there. Sometimes, however, when we have the not equal to, it could be less than or it could be greater than. And so sometimes we have to double the p-value. So when we do this, this forces us to double the p-value. Okay, and now why do we double the p-value? I haven't written down the formula for it yet, but we're going to get it z equals p hat minus p divided by my standard deviation adjustment. So we're going to go off the, and I made a mistake the other day, and I didn't think it was this class. I did it off the sample when I actually need to do it off the population parameter that I believe it to be. So that's what I'm going to do. That z statistic is calculated by that. Now, now I'm going to be able to look that up in a table, and I know to subtract it from 1, it's going to be up here. I'd leave it alone, it's going to be there. But in a case where it's not equal to, then I could be below and I could be above. So that's when I have to double that p-value. But we'll get into those. And actually, my calculator is going to do it for me. So I think from now on, we're just going to let our calculator go. We've also talked about our null hypothesis. Again, is going to be p equals some number. Your alternate hypothesis is going to be a greater than statement. It's going to be a less than statement. Or it's going to be a not equal to. All right. So what do we do first? I could jump out and do the Flint, Michigan water example. Mrs. Sepp said I really need to do that. My problem is I'm not in the mood to do it. All right, well, let's do it and see how it goes. So let's pull up the Flint, Michigan water thing. In 2014, to save money, Flint city officials switched the water supply from the Detroit water system to the Flint River. The following years became a battle in Flint between the residents raised concerns about the safety of their tap water and government officials who insist it was fine. Today, we're going to simulate the investigation of Flint waters that was performed by outside researchers at Virginia Tech. We will perform a significance test to see if there's convincing evidence that the proportion of homes in Flint, Michigan with high lead content in their water supply passes the EPA threshold for safety. All right. So again, just a timeline. In 2014, they switched it to cut costs. They switched it to the water supply from Detroit to the Flint River. In 2014 and 15, residents start complaining about declining water quality. 2015, the mayor drinks the water on TV to prove the water is safe. That really proves it's safe just because you drank it. But anyway, here we go. We're going to collect some data. We're going to use a random number generator to select 5 homes from the population of Flint. For each home, record whether it was high level lead or low level. High level, okay, so we're looking for this. Greater than 15 parts per million is what we're looking for. Okay, low lead is going to be 15 or less. Okay, so that's where so when we do this, we're going to write an H for high and an L for low. So for example, I am going to go out to my calculator. Nope. Wherever my calculator is. So again, we're going to go into not mode. We're going to go into math. We're going to go to probability. We're going to go to probability. We're going to select a random integer. Now I have to know what to do. Let's go back to notability. I think I pulled this in here. There it is, our Flint home data. If that's even readable. Oh, it is readable. So we see that we have homes here. We have homes we have 1,000 homes to choose from. So I doubt we end up with the same, each of us picking the same one. Where did this go? I don't know what, all right. We're just gonna clear that out and start over. We're gonna go back to math, probability, random integer. We have 1 through 1,000. And I want mine to pick 5 of them. Okay, so I need to go, and I'll write this down. I'm going to go look for homes 830, 430, 772, and 205. Well, I missed one, 489. So I have 5 homes that I'm going to go look for. So I'm going to go back to my thing. and I'm going to find those 5 homes. So I need you. So what's going to happen is you guys are all going to do this as well. We're going to combine all. We should end up with, well, if everybody's still on, I didn't even pay attention if anybody bailed. But there's 10 of you and 1 of me, so we should have 11. So we should have a sample size of 55. So that's what we're going to do. We're going to combine this, and if we end up with the same number, it is what it is. But I'm going to go find out. So home number 830 for me, if I look at that, if I can find it, 830 is 10.4. So now we got to go back and remember, what was that? What was my cutoff? 13. So that means this is a low level home. And I'm going to write down the number just in case I remember that, unless somebody has that handy. Was it 13? All right. So I'll let you go about doing that. And hopefully in 5 or so minutes, we'll check back and we'll collect everybody's group and make it a sample, a large class sample. Interesting. So actually, let's do this in the chat. You just need to tell me how many of your 5 homes, how many of your 5 ended up being a high level home. We are worried about the number of, well, no, we'll record both. So high and low. So if you put in the chat, how many low level home, how many high levels? There we go. Okay, so not sure. I think we got, I don't know, there might be one missing, but right now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means we have a grand total of 50 homes in our class sample. We got 2, 4, 6, 8, 9 high lead homes, and so that means that we're going to have 41 low lead homes. So we didn't quite make it as far as and we'll talk about it when we get to end of. Oops. So there's our last one. 3, so we got 12. And that means that, oh my God, I can't even think. 55, and so that means that if I erase this, that's going to be a 43. No. I think I added that to 2 high-level homes, so I don't know why I wrote down 3. That's my bad. There we go. So if we go back, sorry, what? 2, 4, 6, 8, 10, 11. So we got 11 high lead homes out of 55. So that means that we have 44 low lead. All right. So now we're finally where we need to be. We have 11 and 44 in our class of 55. Okay. So if we come down here and we write down, again, our statistic here is going to be our p hat. What is our p hat going to be? 11 out of 55. Who won today? I want to say it's 0.2, but I don't test myself. Did we double check that? It's 15 parts per million. All right, so interesting. All right, so 11 out of 55 was going to give us a, oops, why doesn't that make sense in my head? That is 0.2. Oh, that's just the wrong thing. I got you. Sorry, I'm spinning that off. I'm looking at 2 different things, so I'm trying to get that. All right. So if more than 10% of the homes in a city have a high lead content in their water, the city's water supply is considered unsafe. Based upon the sample your class collected, is there convincing evidence that the water system in Flint is unsafe? All right. So here we go. What's our parameter of interest? The true proportion of homes with high lead greater than or equal to greater than 15 parts per million. So that means my hypothesis is, my null hypothesis is that it's going to be my proportion is equal to 10, if more than 10% of the homes. So that means that we're going to go, my proportion is going to go against 10%. My alternate hypothesis is going to be, oops, see, I'm already messing this up. Got too many things in my brain, can't handle it. Okay. So again, my assumptions. random sample of Flint, Michigan homes. Number 2, approximately normal. And again, we're good there because we had 11, which is greater than or equal to 10, and with a width, excuse me, not width, or could high lead, and then we had 44 low lead. Okay. Name of the procedure. So again, we're going to conduct a one sample. Actually, we'll reread that. We could. Doesn't matter how. Okay. One sample z-test for proportions is one way to write that. Acceptable language is also a one prop z test is acceptable. And the reason I say that's acceptable because what's going to happen is we're going to run to our calculator, and that's going to be our calculator speak of what we do. In this particular case, we have a general formula and a specific formula. I'm just going to write this out. Z is equal to the observed value. My p-hat level was 0.2 minus, I'm expecting it to be 0.1, 10%. And then my adjustment is going to be then based upon the 10%, my null hypothesis. My standard deviation is based off my null. So there we go. So that's what it looks like. That's what we're doing statistically wise. Okay. And I'm not too worried about that. So what we're just going to focus on here is we're going to jump out to our calculator and do it in our calculator and go from there. So if we jump out to our calculator, if we jump out to the calculator, there it is. Again, we're going to go into stats. We're going to go over to tests, and we're going to choose that one prop z test. So it's option number 5. Okay, so I'll arrow down to it. Is this guy here a one proportion z test is what we're going to perform. Okay, now my null hypothesis. Okay, I'm worried about 10% of my homes being greater than the lead level amount. So we're going to put that in at 0.10. Okay, in my sample, X is going to be the number of successes that we had. So we had 11 successes. Sample size out of 55. We're worried that that proportion of high lead homes is greater than, so that's why, and that actually goes back to my alternate hypothesis. So this is where it links into my alternate. I'm worried that it's greater than, so that's why we put the greater than side there. Okay, and so it's only going to do it once. So when we go through notes, we might have one that I show you with a double, but if we go to my calculator, and here's what we have. So if we were to draw that on a curve, if I could highlight this, if I could snap this picture, we get a z-score of 2.47, which is really rare because that p-value is a 0.0067, okay? It also figured my p-hat as well as my sample size, so if you did this from the very get-go, it saved us a step. But let's go back to this, all right? So we're going back to our general formula. So we got a z, a test statistic. What was our z-value? I've already forgotten. 2.47. Whatever. 2.47. So if we drew a picture, again, we're expecting 10% to be in here in the middle. We ended up with a value of 0.2. What's the likelihood that we get 0.2 or higher? And so what happens is this is a z-score of 2.47. If we go and look that up in the table, that is going to have a p-value of, and I forgot to it, 0.0067. So we obtained a p-value. That p-value is 0.0067. Now up here, we established an alpha level. The alpha level is 0.05. So when we come down here to make a decision, we should, so we're going to compare 0.0067 And we're going to compare that to my alpha level of 0.05. And that turns out it is less than. So that means we are going to reject the null. And this is where our conclusion gets a little bit wordy. Wordy. Okay. Since the p-value is less than alpha, we will reject the null hypothesis. There is sufficient evidence to suggest the proportion of homes in Flint with high lead levels is greater than 10%. Okay, so we have just conducted a hypothesis test. Okay, and we have gone through all the pieces, parts to it. It's called a phantom. In reality, again, the picture thing is always nice to do. However, it's not going to be a requirement to do as we're going through phantoms. In reality, as we come through here, we had to name the procedure. That's all we had to do. And then we had to list a test statistic. This all right here is going to be a calculator. Okay, in my opinion, that's what we should just do. Okay, we can go ahead and show this and do that work. That's fine. And I haven't decided if I'm going to make it a requirement on the test or not. Typically what happens is on one sample, I'm okay with it because it's relatively simple. When it gets to be two sample, it gets to be a pain in the bottom. So then I don't worry about it, but there we go. In the Virginia Tech study, a random sample of water from 252 homes in Flint. Of those, 42 contained high lead. Compared to our class data, does this study give more or less convincing evidence of an unsafe water supply in Flint, Michigan, and why would that be? What's going to happen to this? Let's do this. 242 out of 252. Let's come over here. Stat. Before we do this, do we have any idea what we're going to come across? So we're going to get a bigger z-score or not? Heck, it's still 10, isn't it? Clear. I already forgotten. Was it 24? 42 out of 252. 42 out of 252. So before I hit the calculate button, can we have an idea of what's going to happen? Is my p-value going to get smaller or larger? Okay, well, there it is. My p-value got even smaller. That was because my sample size got way bigger. Okay, so that again, it's if we can ever increase the sample size, that's going to, it's always going to help us out to increase our sample size. In reality, though, the sample size was 252. So obviously, I'm guessing there's going to be more than 1,000 homes in Flint because that actually violated our independence rule. But there we go. All right, so here's what we're going to do. I'm going to do one more of the notes problems here. We're going to do a hypothesis test in our notes. And then that will leave us one sample to do on Wednesday. And then we could do 2 samples on Wednesday and then be done. And that way we can review on the following day for our test or do our AP problems and review. All right, so we're going to slip back to our notes. That is not notes. Here's our notes. Here's our notes. There. Find the right one. So we're going back to the potato chip company. Just received a truckload of potatoes from its main supplier. If again, if it's more than 8%, then we have to abandon the shipment and we get a new one. The supervisor selects a random sample of 500 potatoes from the truck. And inspection levels that 47 of those potatoes have blemishes. Carry out a significance test at a 10% level. What should the producer conclude? So again, if we have to, it's up to you on how you use phantoms. But again, I just prefer if you used it as a checklist for what we do. Man, was that box up there the whole time and you couldn't see anything? Oh well. Okay, so phantoms is that checklist that we're going to go off of. So again, we're going to list the parameters that we're dealing with. Okay, so my parameters are in twofold. They are part of my hypothesis, and I just like to list out all the things that we are working with. Okay, so in the parameters, I like to list the p hat. My p hat is going to be 47 out of 500, which is going to give me a 0.094, which right now that sample would indicate that I have to reject the load, but we're going to do a hypothesis test on it. Okay, we know that n is going to be 500, and we know that my alpha level is going to be 0.10. Okay, I've listed off all the things. Now I'm technically speaking, this is where we have to do our hypotheses, there's another parameter in our hypotheses. All right, so hypotheses, the null hypothesis. Again, we're going to worry about that proportion is 0.08 or lower. My alternate hypothesis. Again, we are worried about, again, we have to make a decision if that is going to be greater than 0.08. So P is actually the true proportion of blemished potatoes on truck. Okay, so we have taken care of my parameters. We have made hypotheses, and now we need some assumptions. So we needed to have a random sample of potatoes. Which we did. Here it is. So highlighted random sample. It needs to be approximate normal. And again, we did a good job in this class of writing the word approximately. It's we gotta have that. We can't just go normal. Okay. And in this case, we had, again, 47 bad potatoes. And that means that we had to have 453 good potatoes. Again, each subgroup, so if it gave me a proportion off the bat, then I have to multiply it times n. And then 3 is going to be independent. So we'll have to assume that 500 is less than 10% of the population of all. So actually, again, I don't like n. I like to be as specific as possible. I think n is acceptable, but all potatoes on truck. Oh man, I'm long-winded today. All right, so we have to name a test. My name is going to be Joe. No, my name is going to be a one-prop Z test. We need a test statistic. Which is a Z-score. Here is where we go with, am I making you write this out? I believe I am. Okay, so Z equals 0.094 minus, because that's my observed proportion. My expected proportion is going to be 0.08. My standard deviation then is going to be based upon my population, what I expect it to be. So 0.08, 0.92 divided by 500. Okay, so all I had to do is write that out. My calculator is going to show me everything else. Okay, so we're going to flip over to my calculator. We're going to go stats. We're going to go over to tests. We're choosing a one prop z-test, which is option 5. The proportion that I'm worried about, my null proportion is 0.08. Going back down to my sample, in my sample, I had 47 blemished potatoes out of 500. I am worried about that blemish rate being greater than my null proportion. So that means that we're going to leave that as greater, and I'm going to hit calculate. And then I just have to remember these numbers, okay? My Z was 1.15, my P hat, which we already knew to be 0.124. Okay, why do I have 0.94? No, okay, 0.94, my P value is 0.12, sorry. Okay, so again, it doesn't, I don't remember my TI. The TI is not any different, okay? The P value is that 0.124, okay? So those are the things that we have to, or 0.125, 124, okay? So that's what we have to remember, 1.15. So this equals 1.15. So we have obtained a test statistic, okay? Next, we're going to obtain a p-value. My p-value, again, if we go back to that printout, was a 0.125. Okay, on a side note, again, if we were drawing a picture of this, here's what we have. Again, and this is what we did last, chapter 5, coming right out of Christmas. 0.08 is what I'm expecting. We ended up getting a sample that came in at 0.094. Well, is that overly excessive? I don't know. So I went to my calculator. I found a z-score to be, I found that z-score to be 1.15. I found a p-value. So my p-value here is going to be 0.125. Okay, so the likelihood of getting this is going to be 12%. I'm going to get that 12% of the time. Okay, so we have, that's what we did there. So now what happens is we have to make a decision. Oh my God. We have a test statistic, we've obtained a p-value, we're making a decision. My decision is to what? And actually, we'll just do this all in one sentence. Since the p-value is greater than alpha, we will, what will we do? We will fail to reject HO. There is insufficient evidence to suggest to suggest what? It's going to be my alternate hypothesis. To suggest the proportion of blemished potatoes is greater than 0.08. Okay. All right, so we're going to stop with that one. We aren't going to go through our second one. Actually, the next example is going to be a two-tailed test, which would be nice to give us that example of what when we're calculating it in my hand, how that's a little bit different than if we just dropped it into the calculator. Wednesday actually is going to work a little bit different for me. I am giving the American Math Competition exam. First hour, if anybody has an interest in doing that, oh God, I don't know how. I think you'd actually have to come to school. Yes, because I have to proctor that. I have to see you do that. So if you have an interest in taking that exam, that is going to be Wednesday morning, starting at 7:30, and then it runs through 9:20. So it runs through that first hour. It's like a 50. It's a was that 80-minute test. So if we get going, we get it done during first hour. But anyway, that eliminates me from doing a live lecture with you. So what's going to happen is I am going to record myself doing the rest of the notes for the unit, and I'll post that to the module. And then what happens is I can still do my check-in with you. I'll start my Zoom at 45, and you guys can just check in for attendance, and I'll check you in on attendance, and then just go to the module and take notes from the module is the expectation. But I am not going to be performing a live lecture but you do have to go ahead and do that. And then if you want to go over your test sometime between now and going over the test would have to be a week from now, Monday. The other one, just shoot me an email and we'll just set up a time that we can so I'll just open up my Zoom and we can talk real fast about your test, or you can just wait till the next time I have class and have some time to do that. But I'll leave that up to you. So again, I just wanted to, whoops, I can stop recording this. Nobody needs to hear this.